In the lush landscapes of the late Cretaceous, roughly 90 million years ago, a strange and remarkable dinosaur roamed the floodplains and coastal forests of what is now North America. Nothronychus, a member of the therizinosaur family, stands as one of the most intriguing evolutionary experiments among theropods, a lineage typically dominated by fierce predators. Yet here was a creature that defied the archetype, a giant, feathered, clawed herbivore, demonstrating that evolution rarely conforms to expectations. The anatomy of Nothronychus reveals a story of adaptation and innovation. Unlike its carnivorous cousins, it possessed a beak-like mouth lined with finely serrated teeth, ideal for stripping leaves and vegetation rather than tearing flesh. Its long neck allowed it to reach high into coniferous trees and low shrubs alike, granting access to a diverse range of plant materials. Forelimbs were elongated and equipped with massive, curved claws, tools not for predation, but for pulling down branches, grasping foliage, and defending against threats. These claws, sometimes exceeding 1 meter in length, are among the most iconic features of the species, emphasizing both utility and visual impact. Feathering was likely extensive, covering much of the body and providing insulation, display, and perhaps communication. Fossil evidence, combined with phylogenetic analysis of related species, suggests that Nothronychus may have had filamentous or pennaceous feathers, a striking contrast to the scaly skin often associated with dinosaurs in popular imagination. These feathers, alongside its unique skeletal proportions, underscore the radical divergence from the typical theropod body plan. Movement and posture further distinguish Nothronychus. Its pelvis and hindlimb structure indicate a semi-bipedal stance, capable of walking on 2 legs while maintaining balance for browsing or defensive behaviors. The robust hind limbs supported a weight estimated between 2 to 4 tons, a testament to the strength and stability required to navigate densely vegetated environments. The tail, long and stiffened, served as a counterbalance, allowing precise control during locomotion and foraging. Ecologically, Nothronychus occupied a niche rarely seen among large theropods. As a herbivore, it influenced plant community composition, selectively feeding on certain species while leaving others untouched. Its feeding behavior may have created gaps in the canopy, allowing sunlight to reach the forest floor, thereby influencing undergrowth diversity. In this sense, Nothronychus acted as both consumer and ecosystem engineer, subtly reshaping its environment through daily activity. Behaviorally, Nothronychus may have been more social than previously imagined. Fossil sites hint at potential group behavior, perhaps forming small herds for protection or cooperative foraging. The large claws and strong forelimbs suggest that defensive behavior was formidable, deterring predators including contemporaneous tyrannosaurids. Nesting behavior, while inferred from related therizinosaur species, indicates that parental care may have played a role in survival, with eggs laid in well-protected sites and juveniles potentially guided during early development. Reproduction and life cycle reflect the challenges and adaptations of a large herbivorous theropod. Growth rates likely varied seasonally, influenced by climate and food availability. Juveniles exhibited different limb proportions and tooth morphology, adapting to specific dietary niches until reaching adult form. The long maturation period required stable habitats, reinforcing the importance of intact forest ecosystems for their survival. Fossil evidence also illuminates the evolutionary significance of Nothronychus. Therizinosaurs are an evolutionary anomaly, a branch of theropods that abandoned carnivory for herbivory, developing features convergent with later herbivorous dinosaurs like sauropodomorphs and ornithopods. Nothronychus, in particular, demonstrates the plasticity of theropod evolution, proving that even lineages dominated by predators can explore alternative ecological roles. This radical shift challenges our understanding of predation, herbivory, and niche partitioning in Mesozoic ecosystems. Despite its imposing appearance, Nothronychus lived in an environment of constant change. Seasonal shifts, volcanic activity, fluctuating sea levels, and competition from other herbivores shaped its daily life. Its adaptations, feathers, claws, and elongated neck, were not arbitrary, they were solutions to specific ecological pressures, honed over millions of years of evolution. Each anatomical detail reflects an interplay of function and survival, from feeding efficiency to predator avoidance. The legacy of Nothronychus is not merely in the fossil record. Its discovery revolutionized our understanding of theropod diversity and behavior, forcing paleontologists to reevaluate assumptions about the evolutionary pathways of dinosaurs. It stands as a symbol of experimentation in nature, a reminder that evolution is not linear, but a branching, unpredictable process driven by adaptation, opportunity, and necessity. In its feathered, clawed form, Nothronychus teaches us that life can find extraordinary ways to defy expectations, and that even a lineage defined by predation can embrace a radically different strategy and thrive.